Okay. Hello, everybody, and welcome to hopefully what will be the first of many hangouts here at the University of Akron. My name is Mark Archual, and I'm a blogger for the university's blog, the AK Fastlane. And today I'm going to be talking with one of the engineering design groups at the university, known as the University of Akron Robotics team. Joining me today is Ben Chafee. Ben, why don't you say hi?
Hello.
Okay. Debauchery, I'm not sure how to say your last name,
It's okay.
but last but not least is Richard Johnson.
Hello.
Why don't you guys tell me a little bit about yourselves and your involvement?
I'm the leader of the team, and Debo's been helping me this year with that. I'm also in charge of the mechanical subsystem on our robots. So I organize the meetings. I make sure everyone has something to do. I try to make the schedules and make sure we stay on target, which doesn't always happen, but I try. And then I do the high level and the low level mechanical design for our robots with the other mechanical engineers on our team. And I'm in charge of the CAD models with SolidWorks, the fabrication, which a lot of it happens through Item and WardJet, two of our sponsors. We also do some parts at the machine shop on Akron. And then also the construction, which screws, bolts, wrenches, screwdrivers. So it's fun.
Okay, well, I can go next. Well, I am electrical engineer, so I helped in the past a lot with the board production set of all of that. I helped wired up the last few robots, and hopefully this year too, doing a little mechanical construction with Ben's help. But this year I've done more of helping Ben manage the team, do some of the report writing and editing, and as Ben mentioned, making sure we have the money and on the schedule that we need to be. So it's a lot of fun.
I do a lot of the hardware development for the NASA Robitcs. Yeah, that's about it. So, of the boards and design and all that stuff. So,
Isn't he just down?
yeah, yeah. I make it move.
Richard does a lot. He's what makes the hardware in a robot work. So.
Yeah.
Pretty much.
I hold this wire and I hold this wire. I get together, touch them, robot moves.
There's lots of Eagle Cat designs for PCBs.
Okay. Okay, so what exactly is the robotics competition? I was part of it last year, and I know back then the big focus was making some kind of autonomous robot that could mine materials that might be found on the surface of the moon. But my understanding is that has changed a little bit this year. Do you want to kind of elaborate on that and talk about what teams compete and about how many teams compete and how involved NASA is with the project?
The project is very similar to what it was last year when you were part of it. They shifted the focus to Mars, I think, to stay current with NASA's missions.
Yeah.
We're currently looking into mining an asteroid and going to Mars, which would be more tie-in with those two missions. Goal is still to make a robot that mines sand, and we're working on making it fully autonomous. We're closer than we've ever been to doing that. Stacy, our robot from last year, we already have to the point where it can perform a lot of autonomous functions on its own just by pressing buttons and saying go at it, and it goes and mines sand by itself. We're working on implementing that into our new robot, Christy, which will be fully autonomous. It will have much more sensors than Stacy does so that it performs autonomy efficiently and accurately. But yeah, the objective It's still to mine as much sand as you can in 10 minutes in a simulated Martian environment as opposed to a lunar environment, but I think they're pretty much the same. Let's see, what else did you ask? So
How many
NASA's
teams
involved.
compete?
Oh, how many teams? This year there's 50 national teams that are competing. Last year they were international, but they changed the focus to be solely in the U.S. NASA's involvement is that they want to collect ideas for building robots themselves. I mean, they host the events, they check up on us, make sure we get all the paperwork turned in. Outside of that, they're not much more involved. But we have gone to NASA Glenn in the past to do testing on our robots. So we're open to that. Anyone else have something to add?
I think that pretty much sums it up.
That pretty much nails it.
Yeah.
I was trying to find a video clip of it running autonomously, but I'm afraid it may not be appropriate.
No. So one question I have for you guys is, since they want to try and simulate like a Martian-style environment, what is the sand a lot different than what it was like in previous years on the moon? Because I know when the issue you guys had with the lunar sand was that it compacted really, really tightly into to a substance that was like digging through like solid rock almost to the point. Is the Martian sand different, and is it what did you make any different designs because of it?
As far as I know, the sand they're using is the same as last year.
Yeah, they
Okay.
say that they're using Black Point 1, so BP1, as their simulant, which was the same as last year. So from a design standpoint, I think we kept the same goal, is to be able to deal with lunar or Martian. I guess they didn't really define a difference as of yet as far as the competition rules go.
Mm-hmm.
So
Okay.
They're basically taking the arena from last year, taking the lid off of it and doing it again.
yeah.
They're just restaging the competition in a different environment.
Gotcha.
We did
Okay.
implement some further features with dust tolerance. Mostly in the treads, we added brushes and guards to keep sand from reduce the amount of sand getting in the treads in order to help the robot move while operating autonomously.
Okay. Well, cool. That's definitely interesting that you guys are iterating on past designs. So how has the team been this year? How much involvement and interest have you guys seen? I know we had a pretty big team last year, and but in years past it had been slightly more of a tight knit group.
I'd say it's pretty much the same size, right, from last year, about 12 to 16 people helping out.
Yeah, the team's about the same size.
Yeah, I mean, everyone seems really interested in learning, especially when, since we start putting it together, a lot of people are helping and doing what they can, learning where they can, so they can help out next year as well. So seems to be a good group, and we're always open to teaching people for next year. I mean, so I'd say it's pretty much been the same generated interest.
And what kind of majors do you guys usually see coming through? Because I feel like this would apply itself to, it's a cross disciplinary activity. So I feel like it's got to be a great way to learn how to work with engineers and other majors who don't necessarily always understand one aspect of the robot that could be very important to you could have some kind of interplay happening between people working on the electrical side that's going to affect the mechanical side. So how do you guys work with that and making sure that, like, because basically the robot breaks down into electrical components and more of like a hardware focus or an actual mechanical focus. So how do you kind of work on bridging the gap between those two?
Ben and me do a lot of communication. That'd be carrier pigeon, smoke signals, something like that. And it's almost to the point of this. We've actually Ben and me been working for 5 years on different projects, and mainly this one. And we kind of know what each other are thinking, what we're doing. Um, a lot of times, it's the hardware kind of sets itself up, and then someone has to just go with it to a certain extent. Um, but there's always give and take. Sometimes there's a device that has to be really, really tiny, and he'll notify me that, and we'll design around that.
Yeah, communications improved a lot since my freshman year.
Yeah, I think that's the only way we can function at this point is like constant communications. As Richard said, carrier pigeons or smoke signals. We probably get emails, countless emails from each other daily. And that's just so we're all on the same page and no one's, out of the loop and designing something where it won't fit or won't belong somewhere.
Okay. Yeah, I can't imagine it takes with these engineering design teams. A lot of it's what you put into it is what you're going to see out of it, and you guys are definitely one of the more interconnected and committed groups, especially when it comes to communication about this stuff. Because the competition isn't just about making a good robot, right? What else do you guys have to do that NASA expects you to present alongside the robot at the competition?
Well, a huge part of the competition is, well, the systems engineering paper and our outreach projects. So around campus and around the city, we've gone out and talked to kids, parents, just local people about our project and, advocating STEM and STEM related majors and careers even. And that's usually for me like one of the best parts of it is talking to people about what we're doing and seeing people really excited, even driving a robot around or what have you, and they all seem pretty interested. And a huge part of competition is also team spirit. So when we go there and show that as a team we can coordinate and get along and be happy about why we're there. And sometimes it's not always easy, but we do our best. So, anyone else have anything to add?
We do one of the things that we pride ourselves in always at competition is what we call beautification, almost. Making the robot look like it's got every penny you could only imagine what goes into it. That it goes from all the interlaced logos that Ben does. This year we're also doing engravings, to LED effects, to stands, to all the little things that makes the robot look like you just bought it off the shelf. They actually look forward to it every year because we always do something different. We always do something new. I remember the first year we did a little bit of LEDs. We had thermal printer. We had all kinds of different little things just to make our robot something different. And they look forward to it because, like this year, more artistic panels. This year we went with a higher end LED, so each LED in the whole robot is individually addressable, and there's I can't count how many LEDs are on the thing. Trying to think of all the things. New stands. all that kind of stuff, just to make it look the part. And that's what, going to these competitions and bringing something in, it always is a head turner because it just looks great. It's a great product, and it always, it's always that's the fun part, is making it look pretty. So
This year we also have an added functionality.
Oh yeah, what's that?
Oh.
Ben's pride in this, and I absolutely agree with how awesome this is. But Ben, go ahead and tell
Well, which one? There's 2 of them this year.
Oh, yeah. There's the one we improved from. There are actually 2. The one I was talking about was the new feature I've been wanting to do for the last 3 years. But we have a chair that snaps on top of the robot, so you can ride on it. The robot has wheelchair. No, I'm serious. The robot is powered with wheelchair motors, so it's fully capable of supporting the weight of a person. So we have a chair that can be attached to the top of the robot and you can ride on it.
It is a very comfortable chair.
So we're going to use it in outreach events. We've had lots of people ask if they can ride the robot, so we're excited about that. The other feature we have, which we've tried this in the past, but we're really expanding upon it this year, is having attachable speakers for a music module, so the robot can play music for outreach and team spirit activities. And Richard put a lot of time and effort into the circuit board that controls that system. I don't know if he wants to expand upon that.
Yeah. Think of it as a glorified Bluetooth headset. It's a stereo 30-watt Bluetooth audio amplifier. So you can play audio right off your cell phone to the robot. It can interface with the rest of the hardware on the system. So it also has dual 7-channel equalizer system in it that analyzes 7 different channels on left and right, and it can send those signals down to the rest of the control hardware and let the robot dance and control the lights on the whole entire system. So she can dance and do all that stuff if the software was there. The hardware's capable, of
Well,
course.
the software will be there eventually. Or at least that's the goal.
So can this robot actually, have you guys worked on the mining part? It sounds like it can do almost everything but mine.
Obviously.
The mining functions are very similar to Stacy. The robot actually, if you compare it to our robot from last year, it looks very similar, mainly because we wanted to be able to take the autonomous code from last year's robot and transfer it almost directly to this year's robot. The main difference was adding the stronger wheelchair motors. We wanted those motors so we could push rocks out from in front of it. Rocks are one of the obstacles that a robot has to overcome. Being able to move the rocks as opposed to avoiding them would allow us to open up the most direct path between the mining area and the collection bin. So that way we can get a straight line shot and just go forward, mine sand, bring it back and dump it.
Yeah.
We're still working on constructing the robot. So none of these things have actually been made yet. They've just been designed. But we're waiting on a couple parts to get cut.
Yeah. Well, right now it's crunch time for you guys, so I understand it's not going to be up and running quite yet because things tend to come together at the last minute a lot of times. Well, maybe you should talk about what the competition actually is. We talked about how it's sponsored by NASA, and it's about trying to build a robot that can perform mining similar to what you might find on Mars or on the Moon as in the past. But what actually happens when you take your robot down to be judged at the competition that happens in Florida? Correct? Isn't it? It's near. Remind me of the city, but isn't it near the
Space Center, Cape Canaveral.
Space Center?
You always get his wow. A good-looking robot.
So judging starts. You have to do a communication test. Where they test and make sure you can connect to your robot using their wireless system. And we haven't had issues with that recently. We used to have issues with that in the past, but we've worked those out. And then you do a practice run. So the competition is 3 days, but you have 2 days before the 3-day competition, and during those 2 days you can do practice runs where you can put your robot in the competition arena and practice, because the sand that they have for the competition you can't commercially purchase anywhere. So the only way to test in the environment is to test in the competition arena. So they let us have 2 days to practice, and then the competition actually starts. And you have 2 competition runs, each is 10 minutes long. You collect as much sand as possible. And your final score is the average between the 2 competition runs. So in the competition, you start off on one side of the arena. You travel across, you collect sand, you bring it back, you dump in a collection bin. In between where you start and where you dig sand, there's rocks and craters, which we had mentioned before, that the robot has to overcome. Our new robot can push the rocks and drive over the craters in order to take the most optimum path between the collection bin and where it would mine sand.
Nice. Just brute force your way through there.
Pretty much.
Cool.
The goal.
Yeah,
But I
That's
mean,
why we
if
want-
it can't, it detects it and tries and goes around it. So if by chance it can't haul over a rock, it'll go around it.
Yes, Steve was right. But it should be able to push over.
Right. I mean, that's the first attack, and then if it can't, it has a second method.
brute force method I love that. That's these motors that we're actually using on this robot actually was on a Lunabot in the past.
Oh, yes. Was that on the Dust Devil?
Yes.
No.
Oh,
yeah,
no.
well, actually, you're right. It was Dust Devil.
Oh, okay.
And just to kind of emphasize how powerful these motors are, I sat on them. Okay, I'm a big guy. And then we attached trailers to the back of it to hold all of our stuff on it. And it moved me, the trailers, and the trailers full of all kinds of heavy tools and stuff to the car so that we wouldn't have to carry it. It had no problem doing this. It didn't whine, didn't complain. It said, okay, I'll move forward. Now we're putting this on a lighter chassis with the same gearing, and I'm kind of afraid of how much power these things can really output. We'll be able to haul, certainly. More ways than one.
And how do you guys design the autonomy? How does the robot know where it is once it's in the environment of the in the mining competition? You know, you drop it off in essentially what's a giant dust pit, and it has to move its way around. So how does it know? What kind of sensors do you use, and how do you design for that?
The robot has 11 IR sensors it uses to detect where the walls of the arena are, and it determines its position based on the location of the walls. Since we know the defined location of the walls and the size. It also, we're putting a beacon on the collection bin. It's an IR beacon, so the robot will use that to determine where the collection bin is. It has 2 gyroscopes and 2 accelerometers and 2 encoders to help it travel across the obstacle area to get to where it would dig sand and then return back to the collection bin. There's also encoders and limit switches on the actuator, so it knows where the actuator is at all times. So it can put the actuator up all the way, down all the way, or in between for travel to balance out the weight on the robot.
And luck.
Of course.
We did build a
little bit of
full-size arena to test all this out. So, I mean, we have testing methods that, without luck, we can do.
We have a full-size testing arena in the Express building on campus, which was amazing, and we're very thankful that we were allowed to be able to build that in there. So it was amazing that they let us build it.
I agree.
Right. I want to hear some stories from this competition of when something went horribly awry and you guys had to figure out what you were going to do about it. I want to hear. Give me some flavor here.
Stories I think we'd have from last year is when they made the craters twice as big as they were supposed to.
30-centimeter radius instead of diameter.
Wow.
Right. And so last year our robot was designed to be able to clear a 30-centimeter diameter crater, but when they doubled it inside, it kind of fell into the hole. So, I mean,
Like a golf
after
ball in a
that, we had to be
bunker,
really
right?
careful on navigating
Basically.
around.
Another funny one we had was we were in testing last year, actually in the testing phase of the competition, the first run, I guess you'd want to call it. And we had some time to kill, and we know we couldn't complete another run, and everything was working exceptionally well, hardware and software. And we decided, let's see how fast this thing could really go. So I asked my guy in charge. I was actually driving the robot. That I said, "Hey, are we allowed to go full speed? Because that's not something we normally test, and it's quite dangerous to do because it's uncontrollable. But in this kind of circumstance, why not?" So I said, I got the okay. So I said, okay, we're gonna do full speed tests in 3, 2, 1. That robot looked like a rocket set off behind it, jumped over a rock, and basically flipped itself over and fell on its back.
Yeah. Hey, it was awesome. I thought
It was the coolest thing I've ever seen in my entire life.
But the thing is you also have to remember, so that in the competition, you're basically, there's 3 or 4 people in a trailer, not by the arena, because you're kind of simulating that you're basically on Earth and it's on Mars or the Moon. And so we see him do this, and we're standing outside of the arena, like, what is going on here? Just see it flying and land on its back.
And we're like dying of laughter inside the trailer.
And we're in shock.
It was so funny because the MC for the event, one of the judges and the MC was in our trailer. And they're freaking out right now because they have absolutely no idea what's going on. They thought we completely damaged our robot, and me and Ben are laughing on the floor. Like, this is the funniest thing we've ever done in our entire. I mean, it was like, we know we're starting some rule that next year there's no full speed. It was great.
Fine, it wasn't damaged, by the way.
Oh, good. I was worried about its well-being.
A-okay. She was alive and well.
Great. All right. Well, why don't we start to wrap things up here? Why don't you guys tell me a little bit about where you're at right now, and kind of what your goals are going into this year's competition. What do you definitely want to see work well that you guys have been trying to design for, and besides the wheelchair chair working, what are some of the goals you guys want to try and hit this year that you're going to improve upon from years past, and kind of where you're at with construction of the robot?
I want to see full autonomy work.
Me too.
Yeah, I think that was our biggest goal, is finally get full autonomy. We pretty much designed around that specific goal.
Yeah. I mean, for at least 1 or 2 mining cycles, it would be awesome to see full autonomy work.
We really developed a lot of hardware this year to do that, and even to detect fail and do auto switchovers and stuff like that. So there's actually 2 systems running simultaneously in the robot. So if one would fail, the autonomous system would lock up. The manual system can override and take control. So a lot of hardware has been developed in prototype. A lot of development was put into it to get it to that point, and love to see that work. It'd be really cool. Hopefully it'll never need to be worked, but it'd be cool to see that switch over, and of course it will happen. I mean, the robot boots into manual autonomy, and then the second you click the button, those two processors switch functionalities, and the autonomous system starts up. So really, really, really cool stuff.
Yeah, that sounds awesome.
Construction-wise, we all the boards are populated, so all the boards are put together and they're being tested right now. Mechanically, we have the robot's frame mostly together. We're still waiting on some pieces to get cut before we can put the entire robot completely together. The goal is to have the whole robot fully operational by the end of April, and then work the remaining 2 weeks solely on autonomous testing and debugging.
Sounds good to me.
Right on schedule, right?
Absolutely.
Okay.
Well, based on the fact that we didn't decide to build a new robot till January, so we're doing pretty good time-wise.
I agree.
Okay. Well, obviously, I wish you all the best. What kind of, just real quick before we finish, what kind of advice can you give to students who are interested in joining the competition? I know usually people can join at any time, but if they want to kind of see the project from start to finish, it's best to join in the fall, correct?
Yeah, we usually start talking and planning in the fall. So if you want to put input in and everything, join us in the fall. It can be a little slow in the fall, but if you stick it through, it's a lot of fun. I've loved every minute of it. I joined my freshman year, so I'd say get involved early, so then you get to see the whole thing happen.
Yeah, I would say getting involved early is definitely a good idea because the earlier you get involved, the more up to speed you'll be, and keeping everybody on the same page is really important.
Mm-hmm.
Yeah. The other thing I would like to say is, even if you're not interested in this project and would like to, or are thinking about joining a design team, I would highly recommend it because the amount of like being able to apply your classroom knowledge to a project is amazing, and the amount you learn from doing it it's unreplaceable. You learn so much. It's great, and it's a lot of fun. It's my favorite aspect of school. So.
Wow.
Yep.
Yeah,
And,
definitely. It's not books and studying and theory. It's actually seeing it come to life.
maybe this Lunabot project's not your forte, but that doesn't mean that you can't join the robotics. This is just one of our many projects, and we have the combat bots, we have we have some student-run projects, we have all different kinds of things that you could join, and so you don't have to be limited by one. You could join a couple, or join another project. All kinds of different fun projects. You could join. Combat bot would be a lot of fun.
Sorry, I'd also like to say another thing.
Yeah, go ahead.
If you're interested in this project and are not a mechanical, electrical, or computer engineering major, we take anybody who's interested. We have one chemical engineering major right now and one biomedical engineering major right now, and they've been a huge help this year. So we will take anyone who's motivated or exciting. I'd love to have a marketing major.
Business major.
Wow. Okay.
So we can learn about these things. It'd be great to have someone who just loves to talk to people.
I mean, knows how just for outreach and everything else. Yeah, I mean, business takes planning. I mean, in any team. So yeah, it's just not just engineering. There's a lot that goes into it.
Okay. Well, this has been great. I want to thank you guys for joining me. If you were interested, there'll be some more information on the blog, the AK Fastlane, that you can get at if you want to, look into any of the engineering design teams that we have at Akron, or more about this robot in general. And I'll have to check back in with you guys and see how you end up doing at competition. So I wish you the best and good luck.
Thank you.
Thanks.
Yep. Thanks for doing this, guys.
You're welcome.